If you work with data, you know the drill. That moment, you get a brand new data set, you're excited, you're ready to find some amazing insights, and then you open the file. And that's when the real work begins. Well, today, we're going to talk about how to skip the most painful part. We are diving deep into 5 incredibly useful Python scripts that are designed to automate the grunt work of data cleaning. This is all about freeing you up to do what you're actually there to do, analyze data, and find answers. So let's get into it and reclaim our time.
I mean, this quote just says it all, doesn't it? It is the great unspoken truth of our field. You think your job is about building fancy machine learning models or creating beautiful visualizations, but in reality, a massive chunk of your time, some studies say it's as high as 80%, is spent just wrestling with the data to get it into a usable shape. That's the bottleneck, that's the frustration, and that is exactly what we are going to crush today.
So, here's our game plan. First, we're going to quickly talk about what I call the data cleaning nightmare. Then we'll get right into the solutions, our 5 scripts. We'll start with a missing value handler, then a duplicate record resolver, a data type standardizer, an outlier detector, and we'll wrap up with a powerful text data cleaner. Ready? Let's do this. All right, first up, let's set the scene with the data cleaning nightmare. We've all lived it. You get that CSV file or that database dump, you're all geared up to find some incredible patterns, and then you open it and oh no, your heart just sinks. You see the chaos, and you know your next few days are already booked. Because here's the thing about raw data. It is almost guaranteed to be a complete mess. You've got empty cells everywhere, you have the same customer entered 3 different ways, you've got numbers that are actually text, dates that are in a dozen different formats, and these totally bizarre outliers that make no sense. Trying to fix all of that by hand, one cell at a time, it's not just boring and mind-numbing, it's a recipe for disaster. You're going to make mistakes, and you can't possibly do it consistently when you're dealing with hundreds of thousands, or even millions of rows. It just doesn't scale. That's why we automate. Okay, let's get into our first weapon against the chaos. A script that handles what is probably the most frequent problem you'll ever see, missing data. Let's talk about the missing value handler. You know the question that always comes up first? What do we do with all these blank spots? You could just delete the rows, but then you're throwing away valuable data. The better way is to fill them in or impute them. But how? For a numeric column, like say age or salary, filling it with the average or the median value is usually a good call. For a categorical column, like city or department, filling it in with the most common value, the mode, makes the most sense. Going through every single column and making that decision manually, that is what takes forever. This script takes that entire decision-making process off your plate. So how does this actually work under the hood? It's pretty brilliant in its simplicity. First, the script scans your entire dataset to see where the gaps are. Then, for each column that has missing values, it checks the data type. Is it a number? Is it text? Is it a date? Based on that, it applies the smart, predefined strategy. For numbers, it might use the median, because unlike the median isn't thrown off by a few super high or low values. For categories, it'll grab the mode. If it's a time series column, like daily stock prices, it can even do something called interpolation. Basically, it looks at the value before and the value after the gap and creates a logical value in between. And here's the crucial part. It logs every single change it makes. This is so important for reproducibility, so you can always go back and explain exactly how the data was cleaned. All right, moving on to script number 2. This one is an absolute game changer because it tackles a problem that is way sneakier than it looks, finding duplicate records, especially the ones that are trying their best to hide. Look, finding exact duplicates, where 2 rows are 100% identical, that's the easy part. A single line of code can do that. The real nightmare is finding the fuzzy duplicates. These are records that mean the same thing, but are written just a little bit differently. Think John Smith versus Smith John, or a typo like Amazon instead of Amazon. Trying to find these by hand in a database with thousands of entries is a hopeless task. This script is your bloodhound for sniffing them out.
This right here is a perfect example. We know that Apple Inc. and Apple Incorporated are the same entity, but a computer sees them as totally different strings. So how does the script find them? It uses clever string matching algorithms. A popular one is called the Levenshtein distance. It basically calculates the minimum number of edits, insertions, deletions, or substitutions required to change one string into the other. If the distance is really small, say 1 or 2 edits, the script flags it as a likely duplicate. It's like a super-powered spell checker for your data, helping you merge these records and clean up your database.
Okay, script number 3. This one tackles a problem that seems small but can cause total chaos in your analysis: inconsistent data types. I like to think of this script as the one that brings law and order to your messy, unruly columns.
This is a classic. You try to run a simple calculation, like the average revenue, and your entire script crashes. Why? Because some of the numbers are stored as text with dollar signs and commas, like $5,000. Or you try to filter your data by a specific year, and it doesn't work because some dates are formatted month-day-year, others are day-month-year, and some are just plain text. This script is your universal translator. It goes column by column, figures out what the data should be, and forces it into a single, clean, consistent format.
And here's a fantastic real-world example of how it works, using the pandas library in Python. Let's talk about dates. Instead of you having to write a bunch of complicated rules to figure out every possible date format someone might have used, you can use a single, powerful function, pandas.to-datetime. This function is incredibly smart. It can look at 01-Jan-2023 and 1/1/2023 and know they're the same date. And see that little errors equals coerce part? That's a pro move. It means if the function finds a date it absolutely cannot understand, instead of crashing your whole script, it will just turn that single value into a not a time or missing value, which you can then handle separately. It makes your whole cleaning process so much more robust.
All right, our data is really starting to shape up now. We've handled the missing values, we've merged the duplicates, and our data types are consistent. But what about the really weird values, the ones that just don't belong? That's where script number 4, our outlier detector, comes in. Think of it as your dataset's security guard.
Outliers can be absolutely toxic for your analysis. Imagine you're calculating the average customer age, but someone accidentally typed 200 instead of 20. That single error will dramatically skew your result. These extreme values can sometimes be real, but more often than not, they're just mistakes. The challenge isn't just finding them, but finding them in a systematic, defensible way. This script uses statistics to do just that.
This chart is a great visual. Orders 1 and 2 are in the same ballpark, but that order 3 value of 5 is way off. It's an outlier. Now, a script won't just look at this and guess. It can use a method like the z-score, which basically measures how many standard deviations a data point is from the mean. If a point is, say, more than 3 standard deviations away, it gets flagged. For more complex, multi-dimensional data, you can use something even cooler called an isolation forest. The logic is fascinating. It works by randomly slicing up your data. The idea is that true outliers, because they're so different, are isolated and get separated from the pack with very few slices. Normal data points take way more slices to isolate. It's an incredibly effective way to hunt for anomalies.
And that brings us to our 5th and final script. This one is designed to tame the wildest part of any dataset, the messy, unstructured text fields. This is the text data cleaner.
Let's be honest. Text data is the Wild West. It's just a free-for-all. You get New York, and New York all in the same column. You get random extra spaces at the beginning or end of words. You get abbreviations like ST for street or AV for avenue. Sometimes, if you've scraped data from a website, you even get leftover bits of HTML code mixed in. If you're trying to do any kind of analysis on this text, it's impossible. This script brings order to that chaos by running the text through a cleaning pipeline.
The power of this script is that it's a multi-step process. First, it makes everything consistent. For example, it converts all text to lowercase so that apple and apple are treated as the same word. Then, it can use regular expressions to strip out all the noise, punctuation, numbers, or weird symbols you don't want. Next, it does a white space cleanup, getting rid of any leading or trailing spaces and making sure there's only one space between words. And finally, and this is super useful, it can use a custom dictionary that you create to standardize abbreviations. You tell it that ST becomes street and RD becomes road, and it does it for the entire column.
So let's just step back and look at what we've built. This isn't just a list of 5 scripts. It's a complete automated data cleaning toolkit. We have our missing value handler to intelligently fill in the blanks. We have the duplicate detector to hunt down those hidden copies. We have the data type fixer to enforce consistency. The outlier detector stands guard against strange values, and the text cleaner to bring order to messy strings. Each one of these targets a major source of pain in data prep.
And this, right here, is the most crucial point of all. These scripts are designed like Lego bricks. They're modular. You can pick and choose. Does your dataset only have missing values and messy text? No problem. Just use those 2 scripts.
But the real power comes when you chain them together. You can build a single master cleaning function that runs a new dataset through this entire pipeline automatically. You feed the messy, raw data in one end, and out the other comes clean, reliable, analysis-ready data. Every single time. You build it once, and you save yourself hundreds of hours down the line. And that brings us full circle. Remember that statistic from the beginning? That data scientists spend up to 80% of their time just cleaning data? Well, by automating that drudgery, you get to flip that ratio on its head. Now you can spend 80% of your time on the fun part, the valuable part, exploring the data, asking questions, building models, and finding those game-changing insights. So the real question isn't about cleaning anymore. The question is, with all this newfound time, with data you can actually trust, what are you going to discover?